This video is on the projectile motion. Before starting projectile motion, we should know resolution of vector. Whenever there is a vector quantity, suppose A, and it is inclined at an angle of theta, say, to the horizontal. I'm assuming this to be the horizon. OX is the x-axis, OY is the y-axis. So if this vector A is making an angle of theta with the x-axis, then this A cos theta is known as the horizontal component. And this A sin theta will be known as the vertical component. So a vector quantity, when it is inclined at an angle of certain angle, say theta with horizontal, it will have two components, so A cos theta and A sin theta. A cos theta is along the horizontal direction and A sin theta is along the vertical direction. We also know that the unit vector along x-axis is I, the unit vector along y-axis is j. So we can write this vector A as also equal to say AXI plus AYJ. But AX means the component along x-axis and AY means the component along y-axis. So this AX can be written as how much? A cos theta into I, A sin theta into J. I and J simply indicate the direction. I is indicating the x-axis and J is indicating the y-axis. Now we come on to the main topic, that is projectile. Whenever we throw an object at a certain angle, say theta, with the horizontal, it is observed that the path of the projectile, suppose we have thrown this is a particle, say we are throwing it with a velocity of u. This is the point O, this is our x-axis, this is y-axis. So whenever a certain particle is thrown with a velocity u, which is at an angle of theta to the horizontal, then this body or particle will have two components. One will the horizontal component of velocity, that is u cos theta, and second the vertical component of the velocity, that is u sin theta. Now the body is starting with its motion from O, and suppose it is coming to the point P. Then this horizontal distance traveled by the body is known as the range. The body during the motion is going to a maximum height, say to the point Q. So this is denoted by H. This is known as the maximum height. Now while going from the point O to the point P, if the body takes a time t, suppose we are denoting that by capital T, then this is known as the time of flight. Time of flight means the total time taken by the body to, to go from the point O to the point P. That will be known as the time of flight. Range Range means the maximum horizontal distance traveled by the particle. The maximum horizontal distance. And in the diagram, the horizontal distance is from O to P. So the distance OP will be known as the range. Then height. Height in the diagram is denoted by the point, say, if I denote this point by, say, R. So then this QR will be known as the maximum height. So maximum height will be equal to QR. Now we have to derive the formula for these three quantities: time of flight, maximum horizontal distance, that is range, and the time of flight. So first of all, we will derive the formula for the time of flight. Time of flight can also be defined as the time for which the body is in air. Now it is observed that the time taken by the body to go from the point O to Q will be the same as the time taken by the body to come from Q to P. So time taken by the body or particle to go from the point O to Q is the same as the time taken by the body or particle to go from Q to P. So in case we are able to calculate one of the time, then we can double double it to get the total time of flight. Now the initial velocity of the particle will become how much? We denote the initial velocity by u. And since the body is having an initial horizontal component as well as vertical component, so the initial velocity and its horizontal component can be written as ux, which will be equal to u cos theta. Similarly, the initial velocity uy, that is the vertical component of the velocity, that will become how much? U into sin theta. That is very important to be noted in the projectile motion. This is an important point that the horizontal component of velocity will remain the same throughout the motion. The horizontal component of the velocity remains same throughout the motion. That is the u cos theta component will remain same throughout the motion. The vertical component will however change. And when the body reaches the maximum height, when the body reaches the maximum height, at that particular point, what is the maximum height? In the diagram, that is Q. Then at that particular point, the final velocity Vy, that is the vertical component of the velocity, at that point will become 0. Now, if we apply the first equation of motion, for this path and we take the vertical motion. So from the first equation of motion, we know that V is equal to how much? U plus AT. So since we are considering the vertical motion, so I am writing Vy will be equal to Uy. And since the body is going against the gravity, so A will become equal to minus G. And suppose T is the time taken by the body. So Vy is how much? 0. Uy is how much? U sine theta minus G into T. So if I take GT to this side, left hand side, I will get GT is equal to U sine theta. So the formula for small t will become U sine theta upon G. So this is the time taken by the body to go from the point O to the point, from the point O to this point Q. Now, as I already told you, that the same time will be taken by the body to go from the point Q to the point P. And remember at this point, what is happening? The vertical component of the velocity is how much? The vertical component of the velocity is how much? 0. So the total time of flight of this particle or body will become how much? If I am denoting that by capital T, that will be 2 into small t. So that can be written as 2u sine theta upon g. So this is the formula for the total time of flight of the body. That is 2u sine theta upon g. The second derivation is for the maximum height. We want to derive the formula for the maximum height of the projectile. In this case also, we are going to consider the vertical motion, but since we have to find the distance, so we will use the third equation of motion. You know that the third equation of motion is v square is equal to u square plus 2s. And again, we are going to consider the vertical motion. Now, as we know that the vertical component of the velocity at the highest point is 0, the horizontal, the vertical component of the initial velocity is how much? U sine theta. A is equal to minus g because body is going upward against the gravity. So we have taken A is equal to minus g. And let the maximum height be denoted by say h. So we are denoting s by h. Now if we apply this, if we substitute these values in the third equation of motion, we will get Vy is how much? 0. U is how much? U sine theta square minus 2 into g into h. If we take this term to the other side, I will get 2gh is equal to u square sine square theta. So the value of h will become u square sine square theta divided by 2g. So this is the formula for maximum height. So we are denoting this by the equation number 3. Now the third derivation is for the range of the projectile. As I already told you that during the motion of this particle, what happens? The horizontal component of velocity is going to remain the same. And what is range? Range is the horizontal distance traveled by the body. The horizontal distance means from the O point to the point P. Whatever is the distance that I have written range R. Now we can write that the horizontal component of the velocity will be equal to the horizontal distance traveled by the particle divided by the time taken by the total time taken by the body. Now, since in this case the horizontal distance is range and the total time taken by the body to go from the point O to the point P, that is the time of flight. So that can be written as T. So the value of R will become ux into T. Now it is already known to us that the time of formula for time of flight, we have already derived it. Equation number 2, time of flight is 2u sine theta upon g. And what is the value of u? Ux is the horizontal component of velocity that can be written as u cos theta. So it will become u cos theta into, so the formula for range will become u cos theta into 2u sine theta upon g. So it can be written as 2u square sine u square 2 sine theta cos theta divided by g. And there is a formula in trigonometry 2 sine theta cos theta. Its value is always equal to how much? Sine 2 theta. So the value for range will become u square sine 2 theta upon g. So this is the formula for the range of the projectile. U square sine 2 theta upon g. We want to find that when will be the range of the body maximum. Assuming that the person can throw the object with the same velocity, then the range will be maximum when, since u is fixed, g is fixed, he can vary the angle at which he is throwing the ball or the particle. So the value of range will be maximum when the value of sine theta will be maximum. And since we know that the maximum value of sine theta is 1, and that is going to happen when the angle is 90 degrees. So I can say 2 theta will be 90 degrees. So theta is equal to 45 degrees. That means if we want to throw a body to the maximum possible horizontal range, we should throw it at an angle of 45 degrees. Then one more point to be remembered here is that we can throw a body at two angles. We can throw a body at two angles to have the same range. To have same range. What are the two angles? Suppose I throw a body at an angle of theta or at an angle of 90 minus theta. I am going to have the same range. When I am throwing the body at an angle of theta, what will the formula for range? U square sine 2 theta upon g. In case I throw body at an angle of 90 minus theta, then it will become U square sine 2 90 minus theta divided by z. So that will become how much? U square. If I take 2 inside, that will be 180 minus 2 theta by g. And do remember that's 180 minus theta is always equal to sine 180 minus theta is sine theta. So this is the value of range. So this is the value when for this. So we are observing that range in both the cases are same. So remember that whenever a body is thrown at an angle of theta or 90 minus theta, in both cases the range will be same. One more important thing, the difference between the value of sine square theta and sine 2 theta. We are having the sine 2 theta in the formula for range, and we are having the value of sine square theta in maximum height. Say I say the value of theta is say 60 degree, or say the value of theta is 30. If we have theta 30, then what will be the value of sine square theta? That will be sine square 30. Now sine, this can be written as sine 30 whole square. Now the value of sine 30 is how much? Half. So that will become 1 by 4. And in case you have to find sine 2 theta, for say theta is 30, then that will become equal to sine 2 into 30. That is sine 60. And sine 60 is how much? Root 3 by 2. So this is the difference between sine square theta and sine 2 theta. If you have to find sine square theta, first of all you will write the value of sine theta, then you will square. If you have to find sine 2 theta, first of all you will double the angle, then you will write the corresponding value of it. So these were the three formula whose derivations are very important: range, as well as the maximum height, as well as the time of flight. Now, in the last thing in this particular topic is what is the path of the projectile? The path of the projectile is always a parabola. Now, how we can show? Now, we have to show that the path of the projectile is parabolic. To show that the path of projectile is parabolic. As already I have told you in one of the videos in the coordinate geometry that a particle's path is parabolic when there is an equation in which the degree of one variable is 2 and the variable of one degree is 1. So suppose I take a point, say here. So this point is, I am representing this point basis C. It is having a coordinate of x comma y. So x, if I draw perpendicular from here, then this distance will be how much? X. This distance will be equal to how much? Y. Now, if I take this second equation of motion, I know that the second equation of motion is s is equal to ut plus half at square. And considering the vertical motion, so s can be written as equal to how much? Y. Since I am taking the vertical motion, so I will take uy as the initial component of the velocity into time t. If the body is going upward, so a can be taken as equal to how much? G into t square. Now, since I told you that the horizontal component of velocity remains same throughout the motion, so I can say ux can be written as x upon t. If x is the horizontal distance and t is the time. And ux is how much equal to u cos theta. So u cos theta will be equal to x upon t. So from here I can write t as equal to how much? X upon u cos theta. Now I can substitute this value of t in this equation here. So I will get y is equal to uy is how much? The vertical component of velocity is how much? U sine theta. Now how much is t? T is x upon u cos theta minus half g into t. What is t? X upon u cos theta whole square. Now you can cancel. So y will become equal to x tan theta minus half gx square divided by 2u square cos square theta. So this is the path of the particle which was thrown. Say we are representing this by the equation number 5. Now if we see this equation, we are observing that the maximum degree of y is 1 and the degree of x is 2. Now since this equation is 2 degree in one variable and 1 degree in one variable, so this is the equation of a parabola. This is the equation of a parabola. So it is proved that the path of the projectile is parabolic. So the path is parabolic.